All right, so one of the things that can be hard with this is just getting a sense of how things look visually, and XLSTAT can help us with that too. So let's go back to our parametric test. One sample. I'm going to switch, instead of doing non-dominant hand, just get all of that. I'm going to do dominant hand. I'm on the wrong page again. Dominant hand. All right, so those values for my dominant hand. My options, I'm going to say the theoretical mean is 20. Under outputs, I'm going to leave all of that, but here in charts, make sure that distributions is checked. Let's go back here. Let's say equal. Now we're talking about a two-tailed test because it's equal. All right. And we're going to run this. We get the same information we got before. We get the confidence interval and the mean, the standard deviation. We get our p-value. Also get this lovely little graph here. Okay, this is really helpful. So this is showing our t distribution. The shaded areas are our rejection region. You can see it shows this critical value of negative 2.45 here, right, on both sides. And our alpha value is kind of hard to see. That red line is where we are. So since it's not in the rejection region, then we know that we're going to fail to reject the null hypothesis. Right, this chart is an easy way for us to see it. Let's repeat this, but let's go back to our hypothesized mean of being 35. Okay, so this is assuming the mean is 35. And the values that we get would be out here, right? So we are in the rejection region. It's super small here, so you can't even really see it. So we know that we are not part of what would be considered like the expectation, so the null hypothesis. So we're going to we're going to reject the null hypothesis here. Reject because we're in our rejection region. We're way far out into our rejection region, and conclude that we should accept the alternative hypothesis. We can see that visually here. This can also be helpful when we're talking about our one-tailed tests. So I'm repeating this process again. Let's switch this to a one-tailed test. I'm also going to change our theoretical mean from 35 to 24. And you can see on this version of the test that this is a one-tailed test. So our rejection region exists only in this side. Our critical value is different because of that. Even though our alpha is the same, our critical value is different. Our observed value, t-value, is here. It's just very small. It's hard to read, but it's here. And we can see our alpha is here, 0.05. All right, let's just run the same thing again, but I'm going to switch our option here from being that our mean is less than the theoretical mean to our mean is greater than a theoretical mean. Now we're talking about a right-tailed test. Our rejection region exists only on the right side. So since we are not in our rejection region, it's not shaded here, because everything to the left here is a possible outcome. Here we are going to fail to reject the null hypothesis. So we kept everything the same, but we just changed from being a left test to a right test, and that changes the outcome. Right. So just wanted to show how you can do that with parametric tests, one sample t-test, and then under charts, you want to select distributions, and that gives you the distribution. It's a really great way to think about the data that you're looking at.